This demo showcases the capabilities of R2U2 on the Robonaut2 platform. On the controlling PC, a user generates a set of configuration for R2U2 that include the atomic checker conversion functions, mission time linear temporal logic formula, timestamp width, and operation mode. All these values are compressed into a binary configuration format for interpretation by R2U2. After starting the robot, the configuration file is sent to R2U2. We use a serial line for this, but any communication with the FPGA can be used. After receiving a start command, R2U2 begins returning monitor status in real time. This can be monitored and analyzed from the brainstem. In this demo, on the left side of the screen, we see the control console used to configure and read R2U2. In the center is the SMT scope displaying the output of the absolute position sensors 1 and 2, as well as the encoder position of the joint test article. Our first test case utilizes 2 atomic checkers and 4 temporal reasoning instructions. The temporal reasoning is generated from a file, shown on the console, which defines the final output as the conjunction of the atomic checkers. The atomic checker configuration, seen on the console, define Boolean logic propositions over the system bus variables. In this configuration, we see the sum of the absolute position sensors being compared. Specifically, we are checking if the sum is greater than 40 or less than 80. By summing the absolute position sensors and comparing the resulting value, we can check the phase between the position of the sensors. This corresponds to force on the joint. Now the configuration is compiled, sent to R2U2 over the serial link, the start command is sent, and we begin receiving verdicts from the real-time monitor. At each time step, we see the verdict of the individual reasoning instructions generated by our formula. These instructions correspond to PC 0 through 3, shown on the right-hand side of the screen. With no force on the joint, all the values are true. R2U2 is reporting that we are within our defined limits. Now we apply force to the joint. When this torque violates our configured limits, R2U2 begins reporting false. We will now demonstrate the effects of a temporal operator. R2U2 can be reset and reconfigured on a running system, and we'll take advantage of this. By adding a globally 0 to 3 in front of our conjunction, we verify that the torque on joint remains within our set limit for the next 3 time steps. At startup, we see a 4 time step delay in the evaluation of the globally operator due to the causal information required. However, when the conjunction becomes false due to excessive force on joint, the globally becomes false immediately due to the sufficient information available. Additional MLTL operators, such as until, Boolean operators, such as negation, and Boolean checkers are available, and work continues on integration of additional sensors from the Robonet bus.